For any chemical reaction, you already know that the reactant combine together to make the product. And all chemical reactions follow this law, the law of conservation of matter. Basically, the amount that you put in on the reactant side must equal to the amount that you put on the product side. Now let's explain that in terms of mole. Basically, the number of moles of each element on the reactant side must equal to the amount of moles of that same element on the product side. And if the moles is the same for each of those elements on both sides, so does the mass, so does the number of those atoms. So that is basically the law of conservation of matter. In order to prove that law really exists, we have to balance a chemical reaction or chemical equation. In this video, we are going to focus on how to balance a chemical equation. Now let's look at how to balance a chemical equation. Well, there is only one rule when it comes to balance a chemical equation, and that is you can only change the coefficient number, and that's the number in front of the chemical formula. And that's the only method that you're allowed to change to manipulate the number of atoms on both sides of the product or the reactant. So, as always, if we're trying to balance a chemical reaction, we need to make a list of what's on the reactant side and what's on the product side. To make the list for the reactant and the product, we draw the line between the reactant and the product. And based on the law of conservation of matter, the list would be the same for both sides. They just have different numbers of each of the elements. So in this case, we have calcium, hydrogen, and oxygen. How many calcium do we have? 1. How many hydrogen do we have? 2. And how many oxygen do we have? 1. Okay? Over here, the list would be the same, CaHO. But the number of moles of each element will be different. In this case, we have 1 calcium. How many hydrogen do we have? Well, 2 right there. And we have another 2 more over here that give us a total of 4 hydrogen. What about for oxygen? We have 2 right there, so that gives us a total of 2 oxygen on the product side. Now, this would be a violation of the law of conservation matter. But once you balance it, you can prove that the law of conservation matter really exists. The first type of element that we always balance first is any metal, before we even touch any non-metals. Now, we're going to go to the last thing that we're going to do. The last type of substance that we're going to look at is the elemental hydrogen and the elemental oxygen. These two will all be the last thing that we are going to look at. What about the rules in between? Now, this rule can sometimes be effective in terms of using to balance a chemical equation, but most of the time we just ignore it. So let's look at this particular problem. Well, calcium is already balanced already. What about hydrogen? Well, hydrogen is an elemental form, so we save this last. So let's go to oxygen. Over here we have 2, right? And over here we have 1. So we go up here and find where oxygen is. It is in this compound right here. So what to go here will give us 2 oxygen as well. So we can set up an equation, an algebra expression to solve for the coefficient for those who struggle with math. So in this case, I know it has to be equal to 2. And we can represent this in terms of x, or a question mark, right? And if you notice right here, right, there's a subscript right here that's 1. So 1 times 1 in terms of x will give us 2. And of course, x is going to be 2. So we can cross that out and give us ourselves a 2 for the coefficient. So now let's recount. Because you put a coefficient there, it would affect every single element in that compound. So we have 2 times 2, that gives us 4 hydrogen. What about 2 times 1? Now that gave us 2 oxygen. So again, this is a list for us to keep track. Now, are all of them balanced? Yes, the calcium is, the hydrogen is, as well as the oxygen. What do we do with all the one that doesn't have a coefficient? Well, of course, it's going to be 1. And that's all we have to do. And notice how we ignored this 2 steps right here, because we didn't really use it in this case. So different type of reaction require different strategy to balance the chemical reaction. In this case, it's very similar, right? So we have the same thing. Let's make a list. Based on the law of conservation matter, both sides must have the same list. And Ba in this case 1. Hydrogen again is 2. And oxygen is just 1. And then over here Ba we have just 1 only. How about hydrogen? We have 2 here and 2 there that give us 4, and oxygen give us 2. And the same thing that we did before, because I pretty much just changed from barium to calcium. So the same approach. Notice how the problem is very similar to this problem, that I replaced calcium with barium. This is just to show you how I can manipulate the chemical reaction to make the problem different. But the approach to solve it is pretty much the same. So again, the same thing. We always start with the metals, which in this case, the barium is already balanced. And we have to save all the elemental one last, which in this case is your hydrogen. So we have to go to the oxygen. So we have 2 oxygen over here. What's going to go right there? What's that going to be? So that subscript right there is 1. So 1 times x equal to what? 2. So notice how I set them equal to each other, right? So x is going to be 2. So therefore this right here must be 2. And if that's 2, that's going to change the values hydrogen to 4, as well as the oxygen to 2. Now you have a balanced chemical reaction that proves the law of conservation matter really exists.